Hello and welcome to lesson 4.6, length and midpoint of a line segment. So this section is definitely different in the 1WA course as it is not covered in the 1W1 course. This is something extra for sure, the entire lesson. Okay, so we'll start out with this minds on. A triangle has a length of 3 centimeters and a height of 4 centimeters. What we're going to see is we're going to check to see if the length is doubled and the height is tripled. What effect will this have on the overall area? So what I encourage you guys to do now is pause your video, try working out the area of one, try working out the area of the other, and compare the two. Okay, so now that you tried that, let's see what you should have gotten. So if what I'm going to do is I'm going to see how many times difference this is. We're going to look at the area of the original. So if it's a triangle, it's given by half times what are the bases. Base is 3 in this case, and the height is 4. While the new triangle is double that length, so the double 3 is the value 6, and triple the height is now 12. Well, you can cancel out the halves. A half divided by half is just 1. 6 divided by 3 is just 2. And 12 divided by 4 is just 3. So this is 6 times bigger. Which you might notice the 2 actually came from the doubled part, and the 3 came from the tripled part. Okay, so I'm moving right along. So today what we're going to do is we're going to talk about the length and midpoint of a line segment. First off, we're going to talk about the midpoint of a line segment. So let's say we have endpoints of a line being x1, y1 and x2, y2. So one of them is one point and the other one's another point. Okay. A general formula to calculate the midpoint of a line, usually given by the capital M. All you do is you take the average of each of those points. So x1 plus x2, and then divide that number by 2. That'll be your first coordinate. And your second part of your coordinate, y1 plus y2 divided by 2. Again, remember that these things are subscripts and not superscripts or exponents. So you have to write them properly. If you don't write them properly, it means something totally different. Okay, so let's use this in this problem. What we're going to do is we're going to calculate the midpoint of this line segment with the endpoints 3, 5 and negative 2, 7. So I'm going to assign one of these points x1, y1, and the other point x2, y2. And I'm going to rewrite that general formula. Okay, now I'm just going to substitute the values in. So x1 was 3 plus negative 2 divided by 2, 5 plus negative 7 divided by 2. So this one turns out to be at the value of 0.5. And the next one is at negative 2 divided by 2, which is negative 1. So there is the point right in the middle between 3 and 5 and negative 2 and negative 7. Okay, let's take an application of this problem. So the midpoint of a line segment is given by the point 2, negative 3. with one of the endpoints at 4 and 11. What we need to do is we need to determine the location of the other endpoint. So this is going to be x1, y1, and this is going to be the equation of the midpoint. So again, I'm going to start with my general formula. I'm going to substitute what I know in. So 2 and negative 3. This is equal to 4 plus, I don't know what x2 is. I'm going to leave that. And again, I don't know y2. So I'm going to leave that. Well, what this does is it creates two different equations for us. It tells us that 2 is equal to 4 plus x subscript 2 over 2. And it also tells us negative 3 is equal to 11 plus y subscript 2 over 2. So these are two equations that we can actually solve. We've solved equations like this before. So remember we talked about cross multiplication here. So you can cross multiply. So 2 times 2 is 4. This is 4 plus x over 2, or x subscript 2. You can subtract 4 from both sides. So this point I get as 0. On my right hand side, the equation can simplify to negative 6 equals 11 plus y over 2, sorry, y script 2. I can subtract 11 from both sides. So y2 turns out to be negative 17. So therefore, the other endpoint is the point 0 and negative 17. Okay, so moving right along. So if we ever wanted to find out the length of a line segment, what it is it's actually an expression of the Pythagorean theorem. So what it is you got to find out the distance between x1 and x2. And you got to also find out the distance between y1 and y2. Now because it's similar to finding out distances vertically and horizontally, we commonly use x2 minus x1 and y2 minus y1. So I'm going to start it with those. Now because we're applying Pythagorean theorem, so this would have been x2 minus x1. This would be y2 minus y1. We want to find this distance between 2 points. We're using Pythagorean theorem. So that means I got to square these two values, add them, and at some point I'm going to have to work out the square root. So this is the general formula that we have to find the length of a line segment with endpoints x1, y1, and x2, y2. Okay, so what we're going to do is we're just going to find out the length of the line segment with endpoints 2, negative 9, and negative 7, 15. So I assign this one as x1, y1. I assign this one as x2, y2. And I write down my formula again. So here, if you actually wrote the subscripts 2 or 1 as exponents, this is where you'll notice it's a total difference in meaning. Okay, so now we just substitute the numbers in. We put our values under the square root in our calculator alone. So that's what I'm doing right now. So this turns out to be the square root of 757. Now if you want, you can actually work that value out. That's 27.514 approximately units. And thus concludes this lesson.